In this video, we're going to talk about entropy and what it means and how it relates to thermodynamics. So entropy really just means randomness. Now, a lot of people, maybe even your book, will refer to entropy as order, but I choose to think about it as randomness because the signs for entropy make sense when we talk about it being random, okay? When we talk about entropy meaning randomness. So, to get into the kind of the Reader's Digest version of entropy is that we have to kind of understand that the entropy of the universe is always increasing. When we add energy to stuff and when there's transfers of energy, things are striving to become more random. Okay, so no matter what process we do, the reaction somehow is making something become more random, whether it's the reaction itself or something else down the line, the surroundings. So thinking about that just means that eventually, just like existential crisis of thinking about the whole universe, and eventually it's just going to be completely random. Yeah, it's totally crazy. But let's talk about this in terms of a reaction, or just a particle, an atom. Okay, the more places that an atom has available to it because of its motion, the more random it is. Okay, or if you can think about a molecule can be made up of 1, 2, 3, 4, 5 different atoms. Okay, so if you have a molecule that is made up of 2 atoms, that can occupy some number of places. It can spin, it can vibrate back and forth, whatever. Okay, but by default, something with 3 atoms in it, a molecule with 3 atoms in it, has more places that it can occupy. So everything else held constant, this guy here is more random. It has a higher entropy, okay, because there's fewer places than this guy. And as you may think, temperature definitely influences entropy. Okay, remember that temperature is how fast the molecules are vibrating back and forth. The faster they vibrate, that just means that there is more places for the molecule to be. So if there's more places for it to be, then that means that it has more entropy. And all of this leads us to the third law of thermodynamics, because unlike enthalpy, we can actually measure entropy, or what we call absolute entropy. We don't have to just do delta entropy, change in entropy. And so what we know is that entropy of a perfect crystal, meaning it's perfectly arranged, it's highly ordered, okay, or perfectly ordered. All the atoms and molecules are lined up, okay, and as long as it's at 0 K, that entropy is 0. Okay, now this doesn't actually ever happen, but that's kind of our basis for that. Okay, so let's talk a little bit about absolute entropy. Okay, so we can go to the next slide here. So now here we have things that are going to have, we're trying to compare and figure out which ones are going to have more entropy under regular conditions, which means they're being held at the same temperature. Okay, well, this first one here, this is merely comparing the number of atoms. We have an N bonded to an O bonded to an O. There are 3 atoms in that molecule. And N2O4 looks like this, and there are twice as many. There's 6 atoms here versus 3 atoms here. So which one has more possible places or possible arrangements or possible states? Sometimes they call it states. Which one has the more chance to be in more different Yeah, I think that in that context that's right. Anyways, which one has the greater chance of being in different places Well, that's going to be this guy with 6 atoms. This atom is doing this and moving in and this and in and this and in. So, and this one only has 3 atoms doing that. But this example actually speaks to a bigger thing here. So now gases versus solids. So again, this is the same atom, same atoms, I2, I2. But what's the difference? A gas has a higher temperature, and a gas takes up much more space than a solid does because it's moving around in many more places. Actually, a gas can completely determine the entropy change of a system. Turns out that we can actually just guess or predict the sign of the entropy change just by looking at how the gases are changing. But having said this, back up to the question. Here we have a gas which is moving all around, and here we have a solid which is just kind of jiggling in place here. So this guy has less entropy than the gas. Okay, so gases have way more entropy than the solid. So always pick the gas. Okay, always pick the gas. Okay, so that's your introduction to entropy, and hopefully that helps explain what it is.